Hey guys, this is Carrie, and I thought it could be interesting to create a visual model for the spread of disease given everything that's happening in the world right now. So I wanted to use some of the programming tools that we had. I also have kind of no idea how this is going to work out. So I'll probably make more errors in this video, but I'm intentionally doing that because I think it'll be interesting to kind of model what the actual programming experience looks like without having tried it myself the first time for this project. So I'm going to open up Sublime Text and then just save this to my desktop. I already made a folder called virus spread, and maybe I'll just save it as virus.html. And what I was thinking about was we would have an HTML document with maybe an H1, which is like virus spread, but then also we're going to have a picture with a bunch of moving around stuff. So thinking about some of the mathematical art projects that we did, or even the game project, we did that using a canvas. And so we have to give the canvas a width, and I'm going to choose 600 pixels and a height of 400 pixels. It's the same dimension as our game, just because they're familiar to me. And I'm going to create some JavaScript tags. So let's load up our virus page in our web browser and take a look at how it looks. So the canvas is a bit hard to see because it's invisible right now. So to make it more visible, let's add some style, and let's add a border to our canvas. So we'll select the canvas using the CSS selector canvas, and then border 2 pixels, solid black. Okay, cool. So now we can see the canvas. So I think kind of where my mind starts off with this one is let's get some constant variables that aren't going to be changing. So I'll have a const which is called width, and that's going to be equal to the canvas.width. But if we want to access the properties of the canvas on the page, JavaScript needs to have this loaded as a variable already. So let's do another constant variable, which is we're going to let the canvas equal document.querySelector, and then we'll select the canvas element from the web page. Okay, so now that we have the canvas element selected, we can set the width to be canvas.width. We can set the height to be a constant, which is canvas.height. And this is just storing these values, 600 pixels and 400 pixels, as numbers that we can use in JavaScript. Okay, so after this, where our brain might go is we need an abstraction of a person. And when we think about the virus spreading, maybe the person is a little circle from the top down, and they just kind of move around the screen, sometimes spreading the virus, sometimes not. So let's create a class called person. And we're going to create a constructor method for that class, which will tell us how to build that person. So when I think about the constructor method for this person, that person's going to be walking around the screen. So they're going to need an x coordinate, and they're going to need a y coordinate. And I think both of those should just be random numbers. So we need to actually define our getRandom function. So I'm going to go into one of the files that we worked on before and see if we can find our getRandom function or generateRandom function from before. So I'm going to copy that. You can get that from your game if you're curious where you can find that. And this is our function that lets us generate a random number from some minimum number to a maximum number. And this tool has been super useful. Random numbers are really helpful. So we're going to say to generate the x-coordinate, choose a random number between 0 and, let's see, the width, because the x-coordinate is going to go from 0 to the width. For the y-coordinate, let's generate a random number from 0 to the height. And then we'll have a random y-coordinate from 0 to the height. And remember that it goes down the y-axis, just like in our game. We're also going to have some speeds for our x and y directions. So let's do a this dot speed x. And I'm doing a capital X there using kind of the camel case idea of every time you start a new word, that letter is capitalized. So this will be, let's just set this to be 1 initially, and then let's see how we have to change it. And this dot speed y is equal to 1. Our people are also going to have a status of whether they've had the disease or whether they haven't had the disease, have the disease, or have been cured. So let's think about that. This dot status is going to equal, and they're all going to start off as, let's see, what would be a good word for not having the disease? I don't know. I don't know. Healthy. Cool. So I'm going to leave a comment for myself that the status can be healthy, infected, and cured. So they're all going to start off healthy. Now we're going to be drawing our people on the screen, and we're going to have to build this up to have some infected people. But for now, let's just draw them. So the draw function is going to take them and it's going to draw them on the canvas. So we'll do this dot. Well, no, it's not this dot. It's going to be, whoa, hold up. If we're going to draw on the canvas, we need to remember that we're also selecting from the canvas. We're getting the context, which is usually CTX. So we'll do a canvas dot get context, and that's always the 2D context, just like in the game. And we use CTX for that because it stands for context. So we'll do a CTX dot draw or dot, I think it's an ellipse, but I don't actually have this memorized, even though we've done this recently. So let's see, draw a circle on the canvas. And so this is the arc method, but I don't think we want the arc method because that's a hollow circle. Let's see. Okay, cool. Here we go. So fill style. I thought it was ellipse. But I guess maybe it's the arc method. Let's go to our circle project and see if we have that drawn. So that's not the circle project. Is this one the circle project? Nope. Here we go. This is our circle project. So when we draw a circle, yeah, we did use the arc one. So I guess that's the one that we should do as well. So we could look that back up here. All right, so we do, it looks like to draw a circle, what we do is we do a CTX dot begin path. Then we do a CTX dot arc. And there's a lot of numbers there, so if we go down here, it will tell us what those numbers mean. So it's the x and y coordinates for the center, so we'll do a this dot x, this dot y, and the radius of that is going to be equal to, let's say that the radius is always going to be 0.25, or no, actually let's do 2 pixels for the radius to start, and then we'll do a CTX dot fill at the end of that so that we fill in our circle. All right, so we're gonna have to do a little bit of work with this, but let's see how this looks. So let's start by making it a single person. So let person equal new person, and then we're gonna do person dot draw. So we'll give that a save and a refresh, and nothing happens, so we've got an error, first error of the day. 5 arguments are required, but only 3 are present. Great. So 0, let's see what we did here, opening up our old project. It looks like to draw a circle, we did 0 and then 2 times math.pi, and that was using radians. So we're going to do the full arc from 0 to math.pi. All right, so I've got too many now. Okay, let's see if this works. All right, cool, we've got our person, and he moves around, or she moves around. 2 pixels seems like a really tiny radius, so let's increase that radius to 4 pixels. All right, there we go. We've got our person, maybe even 6 pixels. All right, cool. I kind of like that for our person. All right, now because this person is healthy, let's have this person come up with a color blue. So let's do this dot color is equal to, wait, what's a healthy color? I guess blue is pretty healthy. Let's do blue. So we do CTX dot fill style equals this dot color, and now he's a blue guy. Cool. And every time we refresh it, I'm just doing a Command R and checking to see that he appears in a random spot, which is great. All right, so similar to our game, because our person's going to be moving around, our person needs to have an update function. So for our person to have an update function, what we're going to say is, for our guy, his new x-coordinate is going to equal to his old x-coordinate plus his x speed. His new y-coordinate is going to equal to his old y-coordinate plus this dot speed y. And then what we're going to do is we have to check to see if he crawls off the screen. And here, if he crawls off the screen, instead of making him appear on the other side, like our Pac-Man game, what we're going to do is we're going to have him bounce in the opposite direction. But before we get to that, let's just make sure that things are working. So we're going to create our game loop now. So let's construct this similar to how we did with our game. So what we're going to do is we're going to say window.addEventListener, and we're going to listen for the load event. And after the window loads, we're going to run a function on the screen. And the function is going to be, okay, make a new person. So let person equal new person. Then we're going to define something called the game loop. So function game loop, and this is going to be an algorithm that tells it how to update the screen. And our game loop is going to be really similar to our game loop, sorry. So in order to update all the people, right now we just have one person. We're going to create a list of people. So let's create an empty list and do const people. Actually, no, it's not going to be a constant because it's going to change. Let people equal an empty list. And then what we're going to do is anytime we build a person, similar to what we did where we added our sprites to the sprite list in the game, we're going to say this dot, or sorry, I guess we need our toolbox to do this because we're going to be appending to that list. So let's go toolbox here. And if we go toolbox there, then we can grab the script tag to go here to import our expansion pack. And then what we're going to do is we're going to say, whenever we make a new person, append to the people list this object. Okay, cool. I think we're good to go. So now in our game loop, what we're going to say is people dot for each. So for every person, we're going to take each person, and what we're going to do is we're going to do a person dot update, and then a person dot. Actually, we did this in two separate steps, and then we'll do a person dot draw. So let's give that a save and a refresh, and nothing happens. And the reason why is after creating this game loop function, we want to define our game loop. Or not define, we want to call our game loop. So here we go, save and refresh. And oh, our game loop isn't looping because we left off a really key line of code, which was request animation frame and then game loop. And what this does is it says after you run the game loop once, request the next frame of the animation by running the game loop again. So now it should work, where it's a loop that keeps playing for the next frame after frame. All right, cool. So we got our person and they're moving. But how do we fix this? So it's similar to our fix of the game where before we draw each frame, we have to clear the background. So let's do a clear background here. So how do we clear the background? Well, I don't remember how to do it, so we can actually go into our game code. So if we go to our Dropbox file here, and then our game code from game design, game, we'll open our game up. And let's see, we defined a function called clear background, I think, here. Or draw background. Ours is going to be a little different actually because we don't have a background image, so this isn't too good actually, so I'm going to delete this one. Let's define a new function called clear background. And so when we want to clear the canvas, what you want to do is you want to draw a white rectangle, or whatever color your background is, rectangle, that takes up the entire screen. So let me look up how to draw a rectangle. Draw a rectangle with canvas JavaScript. And so if we do that, there's this rect method. So what we'll do is we'll do a ctx.beginPath. We want it to be white, so we'll do a ctx.fillStyle equals white. And then what we'll do is we'll do a ctx.rect, and that will start from 0, 0, and it will be width by height in terms of its dimensions. And then we'll do a ctx.fill because we want to fill in that rectangle instead of draw the outline, which is what stroke does. All right, so every time we want to clear the background, we just call this function. So it looks like the first step in the game loop is to clear the background and then to draw the new location of the person. So here we go. Yay, our person is moving. All right, but now when our person moves, instead of having them crawl off the screen here, we want them to bounce back up. So that's going to take a couple of conditional statements. So if the person's x-coordinate is bigger than the width, what that means is that they will have crawled off the screen in this direction because their x-coordinate is past the width. So what we need to do here is we need to reverse their x speed. So instead of going in the positive direction, they now go in the negative x direction. And we're not going to change their y speed because their y speed is going to stay going up or down here. It will just bounce off. So what we'll do is we'll do a this dot speed x is equal to -1 times this dot speed x. And that will flip the positive negativeness of the x speed without changing the value. And what we can actually say is the same thing is going to happen. We want the speed to change from positive to negative, or negative to positive if it crawls off the other side. And that actually turns out mathematically to be the same thing here. We're just going to multiply the speed by -1 to change it from positive to negative. So we could say is if this dot x is greater than the width, or this dot x is less than 0, do that. And then we'll run a second conditional statement here, which is if this dot y is greater than the height, or this dot y is less than 0, then change the y speed so it's the opposite, so that bounces in the y direction too. So here we go, let's see our dude bounce. Boom, perfect. All right, so what would make this more interesting is if instead of having one person, we had like 10 people. So let's make 10 people. So to make 10 people, let's define a function called, make people. And that function is going to take in a number of people that we want to make, so we can call that function n. And so let's see, how do we have something repeat n times? Well, I think since we have our toolbox, we should be able to use our repeat function. So let's see how that works. So it looks like we say repeat, and then the number of times we want to repeat it, and then we put the function that we want to repeat. So it seems like what we want to do is we want to repeat this n times, and the function that we want to run is that we want to make a person. So let's let person equal new person. And so if we repeat that n times, we should get n people, because we're going to make, if we repeat this n times, we'll make n new people. So the first line here, actually, after it loads, should be make people, and then we'll decide to start off with 10 people. So let's see if that works. Oh, cool, we've got 10 people. And they're all moving the same direction to start, which is okay. That was something that we were going to mess around with once we got things right. So instead of having them all move the same direction here, let's change this. Let's have them all move a random x amount, so math.random, and then a random y direction amount, so math.random for y. All right, so they're all moving around. They're moving a bit slow, so why don't we multiply these random numbers by 3 and see if that looks correct. Okay, that looks a little better. One thing that's true is they're all kind of moving in the same general direction downwards to start. And so to make that truly random, let's see, we could do, we want it to either be positive or negative for each one of these. So let's see, how do we make this positive or negative for each one of these? Well, what we could do is we could just do this times 6 and then subtract 3, do this times 6 and then subtract 3. And what that will do is it'll create the possibility of it moving in other directions. Cool, so you got them moving in random directions. And the math is a little bit obscured here. I was thinking to try to make it a little bit more obvious, but unfortunately I wasn't able to. All right, so the next step, what we need to do is we need to have them bounce off of each other when they hit each other. So if we think about them hitting each other, what that means is the distance between each one of them and the other one is going to be less than a certain amount. So why don't we get our getDistance function from our game and try to repurpose that. So here when we get the distance from the game, we'll copy and paste that. And the distance formula is really useful here. Instead of taking in a sprite and a sprite 2, it's going to take in, and I'm going to use Command D to multi-select this. Every time we see person 1 or sprite 1, I'm going to change it to person 1. And every time we see sprite 2, I'm going to change it to person 2. So now what we need to do is we need to go through, and every time we update a person, we need to check to see if they've collided with another person. So it's starting to seem like when they collide that they'll be within a certain distance of each other. And to tell what distance that is, it seems like maybe having this radius, instead of just putting the radius of the circle here as 6, what we could do is we could call it a variable called radius. And then up here at the top, we could define what that radius is. So let's create a constant variable called radius, and let's let that equal 6. All right, so now what we're going to do is every time we get the distance between them, let's see, every time we update them, how do we go through that list of people? Let's see. So in our update function here, let's give this a shot. We could say people.forEach person. Sorry, person is in parentheses in the for each loop structure. Then what we could say is if get distance between this thing and the person that we're currently up to in the for each loop. Actually, what we need to do is first we need to check to make sure that we're not finding the distance between something and itself. So what we can say is if that distance is true and this is not equal to the person that we're currently up to, then what we can do is we can say this dot x equals -1 times this dot x, this dot y equals, I don't know, actually, this is not going to work quite right, this dot y. So give that a save and a refresh. Unexpected token. Let's see. The parentheses didn't line up properly. There should be a parenthesis there. And let's see. Oh man, this is not good. Okay, if we get the distance between this and person, and this is not equal to person. So we need to not just get the distance. We need to check to see if that distance is less than a certain amount. We want to check to see if it's less than 12 because the size of each one of these is the radius is 6 here and the radius is 6 here. So give that a save and a refresh. And now, let's see. When they collide, I noticed that it doesn't work as I expected. This dot x is not the right variable to be changing. It's this dot speed x. It should be equal to this dot speed x negative and this dot speed y instead of just y. Otherwise it looks like it eats the people. So here we go. Cool. So there is some element of bouncing here that's working. And we could get that math to be a little bit more precise when they bounce off of each other. Let's see, none of them are colliding. Oh, there we go. Little collision, little collision. We can make the math a little better, but it's a little bit too sophisticated probably for this video. So what we should be doing, I think, is maybe when they collide, we'll also change their status so that they become unhealthy. So when we make people, instead of always making them healthy with blue, what we could do is we could generate a random number. So let's see. Let sick number equal generate a random number from 0 to 100. And let's have them start off with a probability of, I don't know, 50% being sick. So what we could say is if that sick number is less than 50%, then they're going to be healthy. Otherwise, they're going to start off sick. So that would mean this dot status is equal to sick. So I like sick better than infected. And this dot color would be red in that case. So let's do that. So now we've got some sick people. And if they're going to transmit their cold to each other or their virus to each other, then what we could say is whenever there's a collision, if this dot status is equal to sick, or person dot status, the other person's status, is sick. So if either one of the people is sick, then what we're going to do is we're going to say this dot status is equal to sick, and the person's status will equal sick. So this is a 100% transmission rate, where whenever two people interact, if one of them is sick, they get sick. So let's start off with not 10 people here. Let's start off with 50 people. And what you're going to notice is we're actually... I noticed that the people aren't getting sick. So what we need to do is, in addition to being sick, what we need to do is this dot color needs to be turned to red for each of them so we can see that they're sick. So what we'll do is we'll do a this dot color is equal to red. And this was actually a mistake. This dot person is not right. It should be the person itself gets sick and then the other person gets sick. That person's status becomes sick and that person's color becomes red. All right, so here we go. All right, so they very quickly all get sick. The mistake here is, right, this if statement should only be checking if they collide. So if they collide, then they should be transmitting the virus as opposed to earlier. So here we go. We put that inside of the collision thing. So here we go. All right, so now when they collide, you can see that they're all turning red eventually. Let's check out this blue one in particular. Someone is going to collide with him and then he gets infected. That's pretty wild. So now everyone is infected. So of course this is no fun because now everyone has the disease. But maybe it is fun actually. So maybe instead of creating a 50% probability of being sick, what we could do is we could have the people start off with, I don't know, a smaller chance of being sick. So let's say that if that sick number is less than 90, then they're healthy. So 90% of the time they're going to start healthy, 10% they're going to start sick. So here we go. We save it and we refresh it. And now as they collide, well, there's some that are getting stuck in their collisions, so that's a little bit problematic. But now everyone eventually gets sick. Let's see if that happens always. It looks like there's some issues with the collision still, but this is just a rough draft kind of. All right, so everyone eventually gets sick. So what we need now is the final possibility that people start to recover from their illness. So let's think about what it would mean to recover from your illness. So let's see. Let's say that people recover from their illness after, I don't know, 10 days of being sick or something. So, or should we just have it a random chance that you recover from your illness? I don't know what's more realistic. Let's make it a random chance that you recover from your illness. So when we update each person, what we'll say is, if this dot status is sick, then what we're going to do is we're going to say generate a random number, and we'll call this let get well equal generate random, and we'll generate a random number from 0 to 100. And let's make it so that there's a small chance that you get well. So if get well is less than 10, so there's a 10% chance that you get well each day that you're sick. If get well is less than 10, then what we'll do is we'll do a get, or this dot status is equal to cured. And then what we'll say is this dot color is equal to green. So when they're cured, they're green. And if they're cured, then what we're going to assume is that they can't get sick again. So here, when they collide and they get each other sick, what we need to say is, and this dot status is not equal. So let's see. If this dot status is not equal to cured, then what we're going to do is we're going to change our status to being sick. And if person dot status is not equal to cured, then we're going to make that person sick if they interact with a sick person. Okay, so here we go. Hmm. So this is a mistake, obviously. Let's see if we can fix this. So it seems like they immediately cure. But this should really only be happening if they collide. So, So if this dot status is sick, or the person in dot status is sick, then hmm. Oh, I see what's happening. They're getting well really fast because the frame rate here is 60 frames per second. So the chance that it's less than 10 is low on each one, but it's actually pretty high that it eventually happens. So let's have them with a probability of less than 1 getting sick or getting better. So now as they bounce around, there's a small chance that they recover. So this guy, he still hasn't recovered, but eventually he'll recover. This one still hasn't recovered, but eventually he'll recover. One was a much better choice, but he's going to get a lot of people sick actually because he's bouncing around a lot before he gets better. And then the last thing that I think would be really interesting to keep track of here would be, let's see, at a certain point, if we cure everyone or if everyone's healthy, then the disease disappears. But as long as there's one infected person, it will continue to spread. So let's do a final look at this by creating some other things on the page that aren't just the H1 and the canvas. So let's create on our page here, below the canvas, let's create a paragraph which keeps track of total people, which is going to be equal to some number. And then we'll do a span here, and we'll give that an ID equals total span. And then I'm going to copy and paste this line of code so that we keep track of healthy. And I guess healthy is not the best choice of word here because we want to count the immune people as healthy as well. But we'll try to distinguish between those. So then sick would be sick span here, and that will be the number of sick people that we're putting there. And then finally, we'll do the number of immune people here, and that will be immune span. Actually, we called them cured before, so let's call them cured, and that will be cured span. So let's select these elements from our page. So let's do, these are going to be constants, they're not changing. So let healthy span equal document.querySelector hashtag healthy span. And then we're going to do the same thing for each one of these. So instead of the healthy span, oh sorry, the healthy span was not the first one. It should have been total span. And we're changing both at the same time, notice. Healthy span is good. Then we need sick span. So Command D will multi-select both of those. And then we'll do a cured span. So we'll do cured span here. And now what we need to do is we need to keep track of how many of each type of thing there are. So every time we go through the game loop, what we're going to do is, well, let's create 3 other variables up here. Let total equal total. Let total equal, I don't know, sorry, 0, healthy equal 0, sick equal 0. So we're just starting off with 0 of everything, and let cured equal 0. And then what we're going to do is every time we run the game loop, we're going to count how many of each type there are. So in order to do that, we'll say healthy is equal to the total people list dot length. And then in order to get the values for the other ones, what we need to do is for each person, we'll go into that for each loop and we'll say if person dot status is equal to healthy, then what we'll do is we'll say healthy equals healthy plus 1. So I guess what we need to do here is we need to say, oh sorry, this isn't healthy here, this is the total people list. So I think that that's total is what we called it up here. Yeah. And then what we need to do is we need to say each time through the list, start off with 0 healthy people, and then here what we're going to do is we're going to count the number of healthy people by adding 1 each time. Start off with 0 sick people, and then we'll count the number of sick people each time. Start off with 0 cured people, and then we'll count the number of cured people each time. And so then we'll have some similar lines of codes to this. So these will be else ifs, sick, else if cured, and we need to make sure to change these to sick goes up by 1, so sick equals sick plus 1, and cured equals cured plus 1. And then what we need to do is we need to actually have these numbers show up on our screen. So the way that we get this to show up on the screen is we'll do healthy total span dot inner HTML, because that's going to be the number inside of it, is equal to total healthy span dot inner HTML is equal to healthy sick span dot inner HTML is equal to the number of sick people, which we counted up here starting at 0 each time, and then cured span will be equal to the number of cured people, which is cured. All right, so here we go. Missing initializer in const declaration. So that's line 23. Oh, I forgot all the equal signs here. Wow. There we go. Okay, and we have some problem. We've got a lot of healthy people, a lot of sick people, and a lot of cured people. So that's not right. Let's see. Oh, this should be inside of the game loop here. So inside of the game loop, we want to reset these at the same time as clearing the background. So now that looks pretty good. All right, so finally what we'll say is we want to pause the game in a couple of cases, or pause the simulation in a couple of cases. So if sick equals to total, then that will mean that everyone is sick. Or if sick equals to 0, that will mean no one is sick. And then what we want to do is we want to pause the game. So maybe what we want to do is we actually want to say if the number of sick people is not the total number of people, and the number of sick people is not 0, then we want to keep animating the simulation. Otherwise, it will stop. And so I think we finally reached the end of our simulation here. So let's do a refresh here. And let's see, we start off with 40 something people, and then the sick people are spreading. Let's see if humanity survives this time. So there's still some sick people, so we can't tell if we've survived it. It looks optimistic. Okay, so now there are 0 sick people. 45 people got cured, and 5 people were healthy the whole time and never got the virus. But if we change some of the parameters, like here, let's say that we start off with more sick people. Let's say we start off with only 80% healthy, so 20% sick. How would this change things? Let's see if humanity survives in this case. All right, so it looks like humanity survived in this case, and what I'm realizing now is that humanity is always going to survive, because eventually, even though it's a low probability of getting well, it looks like everyone eventually gets well. So there's one last kind of depressing situation that we need to worry about here, which is we need to worry about people dying. So if people die, how would that impact things? So let's update our code so that that's a possibility. So cool. Okay, so everyone's going to start off alive. But now here for sick people, what we'll do is instead of just generating a get well value here, we're also going to generate a dying probability. And if that dying probability is less than 1, so it's the same probability that you die or get well each time you have the sickness, Then what we're going to do is we're going to do this dot status equals dead, and this dot color is equal to black. And then we'll also do a this dot speed x is equal to 0, this dot speed y is equal to 0, because you can no longer move. And in order to do this properly, we also need to keep track of these. So let's let dead equal 0 to start. And we're going to have a dead span equal to the dead span element on the page, and we're going to create that dead span element here. And that will be dead span here. And let's see. So finally we need to keep track of it, so we'll say dead equals 0 to start, and then each time through it, else if person dot status is equal to dead, then dead equals dead plus 1. So then finally here at the end, what we want to say is if sick is not equal to total, if everyone doesn't get sick, what we really want to say is if sick plus dead is not equal to the total, then to keep going. And if sick is not equal to 0, then keep going. So let's see what happens here. So we can see that a couple of them are dying off now. It looks like the dead counter isn't updating, so we need to update that. So dead span dot inner HTML is equal to the number of dead ones. So here we go. All right, I noticed that it looks like once you're dead, you can get sick again. So we need to change that as well here. So if this dot status is not equal to cured, or this dot status is not equal to dead, and we'll do the same thing down here for our person here, but it's not this, it's person dot status. Okay, so here we go. Let's look at all the dead people, and they shouldn't be able to change their status. It looks like they are still able to change their status. All right, let's see. So what will make them change their status? Okay, so when a sick person hit it, it turned it. If this dot status is not equal to cured, or this dot status. So let's see. Is it that every time a sick person collides with a dead person? Yeah. All right, so this should be maybe end. If this dot status is, this should be an end, not an or, and I think this should be an end and not an or. Let's see if that will work. So once they die, they need to stay unchanging. Let's see. Here we go, we've got a collision. Yeah, it doesn't change anymore. All right, so this is a bit morbid, but this is actually the kind of tools that computer scientists are using right now to try to create models of this disease spread so that the people in government have an accurate way of assessing kind of the right protocols. So you can imagine that if we do something like social distancing, what that might mean is that instead of moving around so much, people stay kind of where they are. And then once they stay where they are, they don't have the ability to spread this disease as rapidly. And there's some issues with this model that we created, but in terms of something that we created, kind of using some very introductory programming skills, I feel pretty good about this. I don't feel good about these numbers. It's pretty scary. But it is pretty interesting to see how computer science is used to create simulations. So I hope you guys found this video interesting, and I'll see you guys in the future. Bye.